Hello everyone, my name is Teja. I'm from second year CSE. Today I was here to explain another topic from the subject computer organization. And the topic name is division with using restoration algorithm. Let's see what is division algorithm. Division algorithm is used to perform division of one number with another number. As there is easy to perform division with one number with another number using mathematical way, but in computer system we have to follow certain algorithm to find the division. And there are mainly two types of division algorithms, fast and slow algorithm. The both restoration and non-restoration algorithms are slow algorithms. Let's see what is the difference between what is the definition of restoration and non-restoration algorithm. Restoration algorithm means if after subtraction or addition, if the sign bit of a is changed, then the restoration will be previous value of a, which means the restoration will be performed. But in case of non-restoration division, if the sign bit value of a is negative, then a comma q will be shifted left. So negative bit will be carried then, which means that in restoration algorithm, after each iteration, the value of a will be checked and restored. Whereas in non-restoration algorithm, the value it will be shift left only when the sign bit of value is negative. Let's see what is the restoration algorithm. In this section, we are going to perform restoration algorithm with the help of an unsigned integer, which means that I'm using an integer number to perform restoration algorithm in this section. And we are using restoration terms before we have know that the value of register A will be restored after each iteration. Which means that after each iteration, the value of A will be checked and restored. We will also try to solve the problem using the flowchart. And this is the first circuit diagram for a restoration division algorithm. It shows that how the data is flow between Q, A, and M, and the adder or subtractor which we are using. Here, Q is used to contains the quotient, and register A is used to contain the remainder. And here, the divisor will be loaded into M, and the divisor will be loaded into the register. Dividend will be loaded into register of M bit. 0 is the starting value of the register. So it means that he, here M and Q values are given to perform division, and A will be the default value we are taking with zeros with number of bits same as the M and Q. The value of this type of registers will be stored at each time of iteration. It means that after each iteration, the values of this will be checked and restored. That's why it is called as restoration algorithm. This will be the flowchart for restoration algorithm. As n is the number of bits in division, and a is the default value with 0 as number of bits in M and Q. M is the divisor and Q is the dividend. At first step, we are going to initialize the values. And then at second step, we are going to shift the AQ to left shift. And then we perform A minus M. And then checking the value of A. If A value is 0, then we keep A of 0, Q of 0 is equal to 1. Which means that at starting position of Q will be replaced with 1 as it is empty value after left shift. And if the value of A is 1, then Q of 0 will be replaced with 0, and the value of A will be restored by performing A plus M. And after this, we're going to subtract the n value with minus 1. And each time it will be checking that if n value is 0 or not. If n value is 0, then the division will be completed and the value will be stopped. Process will be stopped. If it is not, then the process will be continued. Step to perform division using restoration algorithm. In this step, we know that from this flowchart, at first step, we are going to initialize the values of A, M, and Q values as A is the Q and M values are given, and K will be the value which we are going to take the default value with 0, and N will be used to specify the number of bits in dividend. And in second step, register A and Q will be treated as a single unit, which means that we are going to perform left shift on A and A Q values. And then at third step, after the value of M will be subtracted from the register, and after left shift, we are going to perform A minus M. The result of subtraction will be stored in register A, and this will be performed as A minus M will be directly not possible. We are going to perform A plus 2's complement of A plus 2's complement of M. We are going to perform. And at fourth step now, checking this most significant bit of A or MSB of A. If this bit will be 0, then the least significant bit of Q will be set with value 1 as it is empty after left shift. And if the most significant bit of A is 1, then the least significant bit or LSB of quotient, the register Q will be set with value 0. And the restoring the value of A, that means that the restoring the value of register A before subtracting with M, which means that we are going to perform A plus M when when the more MSB of A is 1. And at fifth step, after that the value of N will be decremented to check the number of shifts, and N will be used as a counter. Now, if the value of N is 0, then the loop will break. Otherwise, the loop will go continue to perform the second step again from the second step again. This is last step, that it means that the quotient is containing in the register Q and the remainder is contained in the register A. Let's see an example. As dividend is equal to 11, dividend means Q is equal to 11, which means that 0 is 1 0 1 1, and the divisor is equal to 3, which means that M is equal to 0011. Here the number of bits in Q and M are 4, so I take in the value of capital N as 4, and M is equal to 0011. We need to perform division algorithm. We have to add zeros to the A and M to increment with of number of bits as n plus 1 bits. Here we have number of bits is 4, then we have to write it with 5 bits as 4 plus 1 is equal to 5. So the value of M will be 00011, and the value of A will be 5 zeros. As Q will be given, it will be treated as with 4 bits as 1011, and the operation will be initially it will be 0 normal. And at first we are going to perform left shift, and the left shift is performed. The value of the MSB of 1 will be moved to the LSB place of A. Here only A and M will be left shifted. There will be no change in the value of M, and the LSB of Q will be vacant place. And after that, we are going to after left shift, we are going to perform A is equal to A minus M, which means that A is equal to A plus 2's complement of M. And we are going to find in the 2's complement of M and then adding it to the A, and then the value of A will be become 11110, and the value of Q will be 011 and dash, which will be an empty value vacant. I'm going to check the value of we're going to check the MSB of A. As MSB of A is 1, then the value of the vacant place is replaced with 0. And the as the LSB of M is 1, the registration will be performed using the A is equal to A plus M. And then after A is equal to A plus M, the A become 00010, and the value of A become 0110, and we're going to perform left shift again. Then the value become 00010, and as A 0 from Q will be shifted to A, and the Q become 110 and an empty place. And after left shift, we are going to perform again A is equal to A minus M, which will be also as called as A is equal to A plus 2's complement of M. Then we are going and after 2's complement of A is equal to 2's complement of A plus M, then A will become triples double one double one one, and then we're going to check the value of or LSB of A is 1, then the Q naught will be replaced with 0, and then which means that the empty place will be replaced with 0, and then we're going to pass as Q A as the LSB of A is 1, we're going to perform restoration, then the A become 00101. After left shift, the A become 00101, and then the value of Q become 1001 as 1 from Q will be shifted to A, and then after left shift we are going to perform A is equal to A minus M. After A is equal to A minus M, the value become 00010, and Q is 100 in an empty space. As MSB or LSB of A is 0, then the value of Q naught will be replaced with 1. Then the Q become 1001, and then we're going to perform left shift of QA. Then it will be 00101, and the value of Q will be 001 and a empty space. After that, we are going to perform A is equal to A minus M. Then A become 00010, and the Q become 001 in an empty space. If we check that the LSB of A is 0, then the value of Q naught will be 1. And at each step, we are going to go before each, which means that at each left shift, we are going to decrease the value of N with -1. And at last, the value of N becomes 0. Then we're not going to perform any left shift, and then the final value will be obtained as A. The remainder will be 0010, which means the remainder will be 2, and the quotient will be 0011, which means that the value will be 3, as 11 minus 3 is with quotient 2 with remainder quotient 3 with remainder 2. The problem will be solved. Like that, we are going to perform division algorithm with restoration. As at every restoration, we're going to check the value of A, LSB of A, and then restoring the value of A by adding A is equal to A plus M. If you understand the topic.